Thank you, Jeffrey, and good morning, everyone. I'll start with acknowledging who my heroes are, and it's Jeffrey and Chase and Dina and David and Stacy and Insa, who literally put this event together and turned what was a dream into a reality. So big round of applause for them. Thank you. And I would also like to acknowledge all of you for taking the time to come here today. And it essentially validates for me that now is the time. If we can't pull it off now, then I don't know when we will, because we've got everything we need to make it happen. We've heard from Minister Watts about the commitment from the government. We've heard from Charlotte about their amazing work in putting together regulatory frameworks and standards to build good anaerobic digestion facilities. So we've got everything we need. All we need is just work together to make it happen. But here we are, talking about anaerobic digestion. So one of the goals for this forum was to also increase the understanding of what anaerobic digestion is and what it does and what it's good for and what we can gain from it. And I really believe that we need to listen first to be able to advocate for anaerobic digestion. So the goal for me today is to help you learn more about anaerobic digestion and what are the little tricks that we need to really nail down to get successful projects off the ground. And not many people will know this, but back in 1960s, 1970s, there was a research group in Invermay down in Dunedin that was tasked by the Ministry for Agriculture and Fisheries to develop a technology that would convert agricultural waste to a vehicle fuel. And so New Zealand was actually the pioneers of biomethane into vehicle fuels. And there were people from Sweden and Scandinavia coming to Dunedin to learn. And so we were there, and then we lost the momentum and kind of took our eye off the ball. And now we've got Denmark smashing the renewable targets in their gas. They're producing 40% of their natural gas currently from biomethane and heading towards 100% in the next 2 years. So it's something that we should be really proud of. This is where it started. So we just need to take the potential and run with it. And so enormous growth in anaerobic digestion facilities for the last really 3 or 4 decades. And why is it? And I think this is the main thing. What I love about anaerobic digestion is that it's a very versatile process. It can take a range of wastes that otherwise produce emissions and cause environmental damage, and it can turn into energy that can be used for multiple applications. And we also harvest and reuse all the nutrients that have been trapped in the organic waste. And so what we are doing here is essentially going from reducing carbon emissions that would otherwise be produced in landfills when organic waste is deposited into landfills, through the elimination pathway that is composting, up to essentially an offset, because anaerobic digestion creates products that can be used to displace fossil-derived products like fertilizers, like fossil gas. And the last pitch for anaerobic digestion for me is that we use food for getting nutrients and energy out of it as humans. And anaerobic digestion does the same thing in a slightly different form. So what we are doing, when we are putting organic waste through anaerobic digestion, we are essentially maintaining the primary function that was put into food, maintaining it and preserving the dignity of food waste, even for food that is no longer suitable to eat by humans or animals. And so what's the magic? This is Reparoa. It got mentioned here a few times. Tanks, pumps, steel, buildings, tractors. It looks like a big heavy machinery plant, and it is a manufacturing plant. But what's inside the machinery? That's what the magic is. It's unlike tractors and machinery that operate on, can be switched on, switched off. You can just fuel it with multiple sources. Anaerobic digestion is a living organisms. It's a living bacteria that are converting organic waste into energy, and we need to treat it as such. As operators of anaerobic digestion facilities, we need to treat it as a cow, not as a tractor, because it runs 8,760 hours a year. We need to be careful what we feed into it to get the best outcomes. It eats grass, it makes gas. There's so many parallels we can do with the whole cow thing, but the main thing is it's a living organism and we need to treat it as such. I'll dwell on this parallel for a little bit longer, bear with me. So anaerobic digestion is a 3-stage process that has to operate in complete symbiosis. Otherwise, the system gets overloaded. And so if we look at the cow and what's happening in the mouth is the maceration. That's what we need. We need to get the food waste into a stage where it's in a slurry kind of space to put it through anaerobic digestion process. And then we step through the different stomachs of the cow, and basically the first stage of anaerobic digestion is hydrolysis, where the complex organics liquefy and get broken down into more simple organics. And then the organics get converted into acid, and from the acid it goes into methane and carbon dioxide. And so 3-stage process needs to be well balanced, and we need to be very careful what we put into our cows and our metal cows. And it is all about feedstock. So feedstock gives you, depending on what feedstock you have, it gives you how much biogas you have, what your fertilizer is going to be made out of. It controls how you process your feedstock. Whether you are taking industry sludges or whether you are taking curbside organics from households. It also, determines the pure economics of the plant. So, how much have you trucked your waste? How far do you have to truck your waste? What gate fee you can generate? So these are all a very important aspects in an AD facility, and you need to understand your feedstock before you start to make sure that you've got all the boxes ticked, because it's essential. So I'm a bit stuck on the feedstock now. I don't need to dwell the point anymore, do I? Team, can you please move me? Thank you. Oh, great, fantastic. So we've put out this picture with EcoGas together. So there are different types of feedstock that do different things to anaerobic digestion. Fats are predominantly very good for making biogas. There is 3 times more energy per ton of pure organics in fats than there is in carbohydrates and protein. But protein have got all the nutrients. It's got the nitrogen, it's got the phosphorus, it's got the sulfur. So you need to have a reasonably balanced diet for your anaerobic digestion facility to have a stable product and process. So I mentioned it, fats are superchargers for production of biogas. So the likes of the dairy DEF sludges that come with lots of fats, they are fantastic sources for biogas. Food waste is kind of the second best, and then it drops down. Interestingly enough, the manure, the animal manure that has been used as one of the main feedstock around the world has actually very little gas yield. But the main driver for digesting manure, which has already been pre-digested by a cow, is to reduce the environmental damage of manure. So countries like Denmark that have very strong agricultural industry or strong agriculture, they produce a lot of manure, and it was becoming quite an environmental threat for them. So they have chosen anaerobic digestion to essentially sterilize the product, make them more stable, and harvest the biomethane as a byproduct. So what are the 80 superpowers? It's a very robust and stable process. If the plant is designed well, it will, with the right organic loading rates and that kind of stuff, it can handle a lot. And especially once it's matured, we call it kind of maturing the system. When you start anaerobic digestion plant, you kind of start with a little cow, little baby cow, little calf, and then you sort of grow it, and over a year or two, the system matures, and then it becomes very stable. It can handle really high strength waste, from anything from obviously dry feedstock to liquid feedstock. It's got very low nutrients and energy requirements. So the anaerobic digestion bugs they only consume about 5% of the energy that is in the food for their own metabolism and their own growth. The other 95% gets converted into biogas. So it's an incredibly net positive energy process. The same with nutrients. They only consume a little bit of nutrients to replicate themselves. The rest stays in the digestate as a byproduct. The other strength compared to other processing technologies is that it's fully contained. So you'll see it in the repertoire facility. The food waste essentially doesn't see the daylight throughout the whole process. It gets unloaded inside a ventilated facility, and from then on, it all travels in pipes and tanks. So it's fully contained, and it's best set up to manage any odors, and it produces high-value product, and I'll touch on that a little bit later. So what do you get? You get digestate. We spoke about digestate. It's a kind of dark liquid. It's a slurry, essentially, and it's used as a mineral or synthetic fertilizer substitute. It's got all the nutrients, all the trace elements and minerals that have come in with the feedstock, and it's preserved. In most instances, it gets sterilized to make it safe through pasteurization, and then it can be applied to land. So what you see on the picture is a tractor spreading digestate. The trick with digestate it's a strength and a weakness in a sense. Is the nutrients in digestate are in a highly plant available form. So once it's hit the ground, the plants can readily take it up and use it. What it makes it susceptible is a volatilization of the nitrogen. So if we were to throw the fertilizer around through splash plate application, we could volatilize some of the ammonia and lose it. So the countries like the UK is actually putting some regulations on how best to use digestate to make sure that all the nutrients go to the ground and not to the atmosphere. And so I mentioned the highly available nutrients. It's got a little bit of residual inert carbon, which enriches the soil. And it's got undigested fiber and humic substances. The humic substances improve the water retention of soils and help to regenerate the soils a little bit better. So digestate is a slurry. We can separate the liquid portion from the solid portion. And the solid portion, which is called digestate fiber, can be again used for multiple multiple applications. So the fiber, depending on what feedstock you are feeding it, obviously food waste in New Zealand, strangely enough, has got very little fiber. We tend to throw away mostly dairy and meat and not so much of the vegetable stuff. So the plant in repertoire is harvesting very little fiber. If we start putting more of the garden waste through anaerobic digestion, you will end up with a lot more fiber. And that's because the bugs struggle to break down the natural fiber in the green waste. And it can be used for multiple applications. It can be used as a soil conditioner. It still has, good conditioning functions. It can be used as a biomass fuel or as animal bedding. It could end up being contaminated with plastics or other contamination, depending on what feedstock you are putting through your plant and what your separation efficiency is at the front end. So it's a bit of a controversial space when we start comparing digestate and compost, because in my opinion, both of the technologies need to exist for us to move into a sustainable and circular economy. Compost has got a lot more of a soil conditioning qualities, while digestate is a true fertilizer with highly concentrated nutrients. It's liquid and and the nutrient availability is a lot higher than in compost. The Bioenergy Association has put together a biofertilizer producers accreditation scheme, and great work by Elena and Brian putting this work together, and it's modelled on a British public standard PES 110 that is essentially certifying anaerobic digestion facilities based on the quality of their process, that the product that they make or produce is actually a fertilizer and not a waste. So it kind of decouples the digestate product from a waste legislation, and in the UK it presents some monetary savings for the producers. So this accreditation scheme has been put in place and it's now available. So we have removed, I believe, one of the main barriers for putting digestate to agriculture in New Zealand. On the topic of biogas is the other component that we get out of anaerobic digestion. It's about 50–60% methane usually. The rest is carbon dioxide and some trace gases like hydrogen sulfide if we are digesting protein. And it can be used through many different uses. You can make electricity out of it, you can make heat, you can convert it into vehicle fuel, you can upgrade it and harvest the bio-CO2. We've heard a lot about bio-CO2 today as well. There are other emerging technologies that are looking to use biogas to produce ethanol, to produce methanol, to produce hydrogen. So it's that's all sort of emerging up in the European market. So we'll probably see quite a lot of development in that space over the next coming years. And I think Enzo is going to touch on it as the whole topic of biogenic carbon and why is it that biogas should be considered biogenic and not counted towards the greenhouse gas emissions. And I'm not going to dwell on this too much, but I think this picture says it all. We are literally recycling CO2 at the upper level of the atmosphere or of the sphere, and not pulling the carbon dioxide from the stores inside in the ground. So this is why this is why biogas is considered biogenic. And this picture is just basically showing what the different impacts we can drive by using biogas through the different applications. So if we were to upgrade biogas into vehicle fuel, we can make the most impact by displacing petrol and diesel in vehicles. The sort of the second best is replacing coal or natural gas in the industrial heat space, or producing electricity, which in New Zealand is highly renewable already, but there is definitely a potential to displace more. This is a biomethane upgrading plant that Claris and First Renewables have installed in the Reparoa facility. It's got a potential to produce 160,000 gigajoule of biomethane per year. And the biomethane gets injected into the natural gas grid. And the team at First Renewables and Ecogas have done a great job getting this project off the ground and essentially pioneering this concept in New Zealand. So we've done the first step. It hasn't been easy by any stretch of imagination, but we are building that knowledge in New Zealand and it's readily available. The byproduct of the upgrading facility is the bio-CO2, which in Reparoa is going to be used to supply the local Turners and Growers glass house, and Ben is going to talk about it a little bit later today. And I think I'm just going to tee Richard up and for the next session, and it's talking about how do you put an anaerobic digestion project together, and it's actually not the piece in the middle. It's not the technology itself. It's everything that is outside of the plant. It's your feedstock and it's your products. And so a key to a successful AD project is making sure you've got committed feedstock of known quantities and qualities, for a reasonable period of time, and then you have secured an outlet, sustainable and long-term outlet for your products. So those are the key pieces that anyone who's building an AD plant needs to consider and make sure that they tick those boxes. And we've heard about the enablers and the obstacles. At the national level, we do need the policy help. At the regional level, we just need to work together and partner for getting those projects off the ground. And I feel like I'm stepping on Richard's toes now, but I'm going to mention it anyway. In New Zealand, a lot of the anaerobic digestion facility project will stand and fall on the feedstock, and I'm dwelled on it before, but it's the gate fees and the avoided landfill disposal cost or other disposal cost that are currently carrying the business cases for anaerobic digestion projects in New Zealand, and that is because the value of the products being biomethane and digestate have not been fully recognised in New Zealand yet. So it's a very market-driven approach. We haven't had the legislative support so far, and I suppose one of the benefits is that we will only ever build AD facilities that are fully viable, economically viable, and we will avoid perhaps some failed projects in that space. We will also, there was an error in couple of decades ago when there was the whole debate about producing feedstock for AD facilities versus food. Given the fact that our projects are relying on gate fees, I don't see that happening anytime in New Zealand. But the critical challenge is that it's a very slow development because you need to compound the feedstock to make anaerobic digestion facility happen, and the products remain undervalued. So I think I'm going to pause here and hand you over to Richard to talk more about the economics.